Greetings. My name is Amin Mahmood. I'm a California-based structural engineer, and I'm going to talk about designing and building earthquake-resisting homes from mud, low cost, especially for rural areas in Afghanistan. I'm going to share my presentation with you now. Building low-cost earthquake-resisting homes in Afghanistan. This is a picture of a mud home, which is very common in rural Afghanistan. The walls are usually half a meter thick, and they are built with layer after layer. Each one of them is about half a meter tall. This one is the traditional wall construction in rural Afghanistan. Advantages: low cost, free local material. The material is mud, mud locally available right on the site, on the side of the house. And locally available labor, very cheap labor. It doesn't need anybody highly skilled labor. And they can usually, the homeowners choose to do it. I remember when I was a kid, I and my brother, along with my father, built our rooms added to our house. Thermal comfort. Thick walls provide excellent insulation. The walls are so thick, like half-foot thick. They are very, very good for resisting heat transfer. They are very cool during the summer and warm during the winter. If you heat it, the heat stays there for hours and hours. You can see the windows are small. Usually that's two purposes. Now, number one is to keep the heat loss to a minimum. It gives you enough light. Number two, to give them some privacy, especially in rural areas. There should be at least 6 foot above or 5.5 foot above floor, so a woman cannot be seen through it. And that's pretty much the standard in rural areas of the country. And also, the walls are thick and is a bulletproof. Unfortunately, in the past 45 years of war, the bullet the fear is common everywhere. People are afraid that bullet might go through their wall. These walls are thick, so the bullet can go embed into it, but doesn't go through it. And also easy to maintain, to be maintained. These walls, the only problem is that they need to be maintained. Like I put like a straw layer of straw mud on the outside to keep it from rain. Usually, every 1 maybe 2 years, they require this layer of to protect the wall. This is very good. The ladies are very good at this, and they do it as a fun. I remember when I was a child, I would help my mother to mix the mud and also stamp in it to mix it, make sure they will put water in it overnight, and the following day when they wake up, the mud is completely uniform and mixed. So these things I'm going to talk later on. These are also important item. The one which is sitting on top of the wall and also the pile behind it. Okay. The construction method is, they call it paksa. In some area, they call it pascha from different dialects, different areas of Afghanistan. Most likely, it's called paksa. So they're made from half a meter thick by half a meter tall layers of mud. So this is half meter thick and half meter tall. Each layer is half meter. So the disadvantage of this one is they crack easily. Mud, by its nature, cracks. So if you add sand to it, then it doesn't become that strong. But if you have pure mud, it cracks. You can see the cracks as it dries, it cracks. And these cracks are covered by these straw mud layer, which is mixed with straw that prevents any cracks. It bridges over these bigger cracks. And other disadvantages, they are very weak against earthquake because they have no reinforcement in it. This is a wall that I took this picture from the earthquake in Paktika. This was in Burmal, district of Paktika in 2022. Again, the disadvantage is the walls are so brittle, it just falls apart easily during an earthquake. It's very similar to a quickie. If the quickie crack, it falls apart. There's nothing to hold it together. There are two things in engineering. One of them is brittle, one of them is ductile. These are not ductile. Ductile means something will bend or crack but will not fall apart. These are brittle. But if there's a hair, fiber of hair in the quickie, they will break but will not fall apart. And this was something very similar that I witnessed in Turkey. After the 2023 earthquake, I spent 10 days in Antakya and the surrounding areas. I visited a lot of damaged buildings before they were demolished to learn from it what was the problem, and also witnessed the demolition process of many buildings. I noticed large pieces of slab hanging from a single rebar, reinforcing bar, with the bulldozers and the excavators were pounding it to get it off. After several tries, they were snapped. The rod was snapped off or dislodged. So one bar was able to hold large slabs of concrete slabs. So they're very similar to a cookie with a hair. Now, here's a picture of an experiment that I will show you a video later on. I made when I came back from the earthquake in Paktika, probably from the earthquake in Turkey, because that was during the winter and this was also during the winter. I made this experiment in my backyard. I made 2 bricks from mud, 1 brick, another brick, and shook them on a shake table. The difference between the 2 mud, this is just pure mud. This is mud, but with some strings, some lines like not nylon, cloth like the thick line that you use, the tailors use for sewing, but a little thicker than that. And to see the performance of this, the brick to the right, the brick very easily. This one broke but didn't fall apart. Although this one, I tried to dry it. You can see they're still not completely dried. It was winter. The sun was not that strong, but I couldn't do it in the oven because they were too big. So I will show you the video in a minute. But this is the process. How is this going to be applied? This reinforcing for this concept of lines into the mud. Here we can put nylon ropes, like the ropes in each layer. We tie to a pin, steel pin at each end, and tie like a rhubarb, like a guitar string, and put the next one on top of it, the next layer of mud layer. So that will keep it. The rope will be kept from sun damage, from ultraviolet rays, and will keep the wall from completely disintegrating during an earthquake. Could crack, but will not will not let it go completely. And this is the concept, how it works. So imagine this is a small building with some 4 walls and some interior walls and a door opening. So these red lines are ropes. There are 3 pins at the corners, 2 pins at this corner to tie these ropes around it. These 3 pins tie this rope and also this pair of rope. Same thing on all corners. Along the door openings, I have vertical members of wood in horizontal to cross over it, and then the ropes tie to these. This will keep from cracking here and cracking here. This is a little more expanded. It's a detailed, enlarged detail. This is 1 layer, 1 parsa, another parsa, another 4 parsas. Each layer has those 2 lines of rope. And if you can see the detail, the green line is the outside and inside face of the wall. This is the corner. And these blue lines are steel pins, like a 12 millimeter thick rebar, like about a couple of feet tall, maybe 40 centimeters, embedded into the wall below, and then the next one go on top of it is embedded into the upper one too. So this rope is wrapped around these bars, and this rope is around this bar and this bar to keep it from cracking here or cracking there or disintegrating there. This is a little more technical detail of it. This is like a T-section. This looks like a T, exterior wall, interior wall. This rope wraps around these 2 pins, comes back this way, so prevents any crack here. It prevents this wall from going that way. And the next one is an L-shape corner. You have 3 pins, 1, 2, 3. This rope goes around these two, and this rope goes around this and that pin. So preventing a crack here and preventing a crack here. And this is the opening, reinforcing the door openings. So I've got a 4-inch by 4-inch posts on each side of the door, outside face of the wall and inside face of the wall, and 2 in the middle between them, and then a shorter ones between these two to make a total of 4. And there's a steel angle with holes in it to be connected to this and there, to this wall in the horizontal one, with screws or nails, and also at the bottom to keep it from opening it up. And the wall will come between these two and also flush with this, so it's like a clamped between these two posts. These bars goes into holes into these vertical ones, so the wrap can wrap around it. The rope can wrap around it because it's interrupted by the door opening. So the rope can be tied to this or wrap around and go back. This each level will have one of these bars on each side, and the bars are 12 millimeter thick diameter. Okay, this is the heating system of a house, a rural house. This is called tawkhana, very common in villages. These are underfloor tunnels from as built a built-in clay oven in the kitchen. The fuel material are cow dung. Most people have some kind of animal in their home, like a cow or donkey or sheep or goats. They burn that. They put those together and they burn it like firewood, and also wood or whatever they can find. The smoke from the fire used for cooking is directed to small tunnels under the floor to a chimney in the wall. So the heat in the smoke goes through it, and the fire used for cooking is also heats up the floor, the home. The byproduct of the fire ashes is piled up outdoors with other food waste used as fertilizer for crops. The food waste like onion, the skins or potato peelings or some other thing which is not eatable, but it's cooking material, or or bones, they throw it out on that, and then after a while they get decomposed. It becomes like a compost, and they use it for crops, for fertilizer. So an excellent way of recycling waste, environmentally friendly. So this picture, what I will do is explain to you. This was so comfortable. When I was a kid, I remember that our home had the tawkhana, and we used to cook. This is the kitchen. Let me explain this one here. So this is a built-in oven. This is the kitchen, and there's a few steps come to the bottom of the oven. There's a hole for the combustion air. The fire needs air to burn. The air goes from here, and also first they fill it about 2/3 from firewood or dung, and they catch the fire, and then they put the lid on top of it. Lid is usually metal with about 8-inch hole in the middle, and on that hole they put their dish to cook their food. And the fire goes for an hour, maybe 45 minutes, to cook the dish. After the fire is done with no more smoke, and the heat and the smoke goes underneath here. The tunnels goes into this wall. And there's another room. It could go there and go through the other. Here, this little area could be a washroom with a built-in tank of water behind this wall, and this heats that one, and also the floor and the floor of the room on this side. So they both they are heated, and this is almost like a poor man's central heating system. They are very comfortable. I remember when I was a child, I used to sit here and then to add more fuel to the fire when my mother would tell me. When the fire is finished and all the smoke is gone, they remove the lid, and then they use it for baking their bread. After that, they cover the lid, and then the heat is maintained, and the floor remains warm all night. It's very comfortable. People in the villages, most people, they do not sleep on beds. They live on the floor. They've been sleep on the floor, and the floor, the mattress remains warm throughout the night. Very, very comfortable, almost like as good as the central heating. And during the summer, there could be another chimney going exterior to the exterior, so it doesn't heat up the houses. But usually during the summer, they have an oven outdoors, so they can cook outside. And this is what I was trying to show you in the beginning of the thing. See these things? These are cow dung. They make these like discs and leave it outside in the sun. And when it's dry a little bit, they put them on the edge to dry well. And then when it's completely dry, they put them in a pile and they put some kind of plastic over it so the rain doesn't ruin it. And they use this one, maybe 3-4 of them every night, up to 5-6 of them, and then that's good enough for cooking the food. A very, very good fire, almost like a charcoal. دا خو ولدس چپه سو دې کې څوم درزونه زیاتو مګر چپه نه سو او هغه یې چې وراس اوس هم نه خوري اوس هم نه چپه کېږي دې کې تارونه وو سپڼسي. So this experiment could be used as a basis for reinforcing walls made of mud. And make him seismic resistant. Thank you very much. I hope you found this presentation interesting. Have a good day. Bye-bye.